back to my object references series. So in part 3 today we'll talk about weak references. So weak references, similar to soft references, were introduced in Java 2. And what are weak references? Well, in a nutshell, it's the other extreme of strong references. It's the opposite of strong references. So the weak reference is an object reference that will not remain in memory once the garbage collector runs. So the garbage collector will remove objects that are only weakly referenced when it runs. So if you have an object that has a strong reference and a weak reference, that object is safe. But if you have an object that has only weak references referring to that object, then when the garbage collector runs, that object, the references will be removed, and then the object itself will be released back to memory. So just a quick comparison between soft references and weak references. The main difference is that the soft reference has a longer lifetime, because the soft reference is only released back by the garbage collector when the system is running low on memory. But the weak reference is released back when there are only weak references to an object. So in that respect, the soft reference objects have longer lifetimes in the system. And before we go to the use cases, let's have a look at the Java doc for the WeakReference class. And this is, if you just bring up the Java docs, this is the class WeakReference, and it talks about WeakReference objects which do not prevent their reference from being made finalized, and then reclaimed. So objects, basically it's saying the same thing that I just mentioned earlier on. Objects that are only weakly referenced will be released by the garbage collector. And the Java doc itself also refers to the canonicalized mappings as a good use case for weak references. So let's go back to the slide. So what are canonicalized mappings? It's quite a mouthful. What are these mappings? Well, in a nutshell, these mappings, they are a one-to-one mapping from a unique identifier and an object. One-to-one mapping from a unique identifier to an object. And a good example is the hash map. So I'm talking about the hash map as a concept in this context. So just to avoid any confusion, let me put the term weak hash map, and you have weak hash map, and then weak hash map. Yeah, I think that's better there. So in this case here, the weak hash map, where the key refers to a weak reference, which in turn refers where the key is a weak reference to an object. And the idea here is that in the weak hash map, the beauty of this is if you're not too worried about the objects remaining in memory, then these can be, using the weak hash map is a good way to improve the memory usage of the system, because as long as the object itself is only referenced by the key and there are no other references, then that object, the key will be released and the object itself also will be released. And this is why that having hash maps can even cause memory leaks even in a Java system, because with the standard hash map, if we don't use the weak hash map, with a standard hash map, the key references are strong references or standard references between the key and the object. So this prevents these kind of memory leaks where the object never gets deallocated and freed from memory. Again, the last point again, just stating that again, that allows objects to be released by the garbage collector when only referenced by the weak hash map. So a good example of, and to summarize, a good example here of the canonicalized mapping is the weak hash map itself. And I have a little diagram here I drew. So you have your weak hash map, and the key is a weak reference to the object. As long as you don't have any other references to this object, then when the garbage collector runs, all this will go. The key will go, and the reference to it will go. So then that will no longer exist in that weak hash map. To wrap up, we'll just give a little code example of how we can use the weak reference in code. Here we just have a string, and we have a reference defined here for that string. So there's the weak reference is a reference to the string object, and the string has a weak reference to it, checking for a weak reference to this string by putting string 1 here and checking if that's going to be null. We should always check if it's null, because there's a risk that this memory could be deallocated, could be released back, and we should always have that in the code. Although looking at this code, you might also notice there's actually a bug here, because this reference is a strong reference. So since this is a strong reference and you have a weak reference as well, this memory will never be released. So really, to make sure that this code actually does what it should, we should set this value to null, and then we have a situation where it's very possible that when the garbage collector runs, if it runs between these two lines of code, then string 1 will be null. So it's a very good example there of how the code itself, if you're not careful, we can introduce a memory leak without knowing. But it's very important also to ensure that there are no references to that object, no strong references, no soft references, only weak references. Then we have the guarantee that it will be removed the next time the garbage collector runs. Well, I hope this has been a good introduction and explanation of the weak reference object reference type. And look forward to seeing you again on my next video in the series. Thank you. Bye.